press record.
All right, yeah, the recording is going. All right. So Jess, and I'm not going to pronounce the. I'm sorry. Or you can actually, how do you pronounce your first name?
Abdul Rahman.
Abdul Rahman. Okay.
Yeah.
So Jess and Abdul Rahman, I'm going to turn it over to you guys, and I'm gonna turn off my video and mic so we can see you better and hear you better.
Okay. So yeah, I mean, I'll just share my screen real quick, and then we can do our introductions because there's a slide for that. Let's do. Sorry, I got 1,000 windows open here. I gotta find the one I want. Really? Well, anyway, while I find this, my name's Jess Likens, and I'm with Polaris Solutions, and I'm a cloud architect. I'm actually up in Chicago, but Clint tossed this my way because he didn't have time to do he was too lazy to do a talk this time around. So we
Mr.
decided.
Edmondson's very busy, Jesse.
Oh, sorry, busy, right? And so you know, I talked with Abdul Rahman, and we decided we would tag team this and do two different related topics. And so we came up with this. There we go. So yeah, we're here to talk about this. But before I go and do that, we're gonna when we go through this, if you want to ask questions along the way, I guess you can feel free to speak up. Otherwise, you can pop into the chat, and then I'll sort of answer questions as Abdul Rahman finds them for me, and then for him, I'll do the same for him. So, but yeah, just real quick, like I said, I'm a cloud architect. I've been doing this for way too many years. I've been in .NET since it came out, and I'm pretty much an Azure fanatic. I know a little bit about Google and AWS, but I'm mostly an Azure dude. And yeah, technology is sort of my passion. I've been doing it forever and ever and ever, and I kind of love what I do. So it's been exciting to be introduced to Polaris. I'm a relatively new addition here, so I get to see all sorts of different new stuff now. And I'll kick it over to you, Abdul Rahman, for your intro.
Yeah, my name is Abdul Rahman Hussain. I'm also lucky enough to be at Polaris. Recently started as well. Seems like a fantastic place to grow and build fantastic software. And I'm excited to be here. And Jess proposed the idea of microservices, and here we are. Let's do this.
Yeah. So before we get too deep into this, I want to make sure that I'm not sure where everybody is. So I just wanted to give a quick overview. I have about 4,000 slides to go through. No, I'm just kidding. I hate slides. I want this to be demo heavy. So this will be quick. But essentially, just so everybody's on the same page, there are a lot of definitions for if you go search for what's a distributed application. This is a decent one, but essentially it's an application that instead of running everything in one spot, it's run across multiple machines, multiple regions, multiple networks, everything. It could be internet, but it's basically a whole bunch of different pieces running on different hardware that talk together that provide what looks like a seamless experience to the user, but behind the scenes is a relatively complicated pile of stuff. So over here, you can see that this little diagram that I stole from somewhere online. That's basically what we're talking about here. So I just want to make sure everybody's aware of what we're talking about. Please, if you do have any questions about any terminology that pops up, feel free to throw it in the chat or just speak up. That's totally fine. We're going to talk a little. I mean, microservices is just one aspect of what a distributed application can be. There are many other pieces, but we'll focus a bit on that, at least for my piece on Tye. We'll talk about why they're complicated and how to uncomplicate them. So before I go on, any questions? Can I pop the chat up at the same time? I haven't used Teams in forever. Well, we'll see. All right. Well, I'll assume there's nothing going on. So this is the benefits, right? We have ultimate flexibility. You have infinite scalability in the horizontal direction. You can scale any node forever and ever and ever if you need more power. You can have reduced latency by putting services in the same data centers as the actual database. You can have fault tolerance where one of your services go down, but the whole system can still go. Everything's loosely coupled. You know, you don't have to worry about, you know, different nodes in the system don't really have to know too much about each other. And you can have an event bus that, you know, you can actually have event-driven architectures. There are other benefits, but these are sort of some of the bigger ones. So I'm not going to go over too much of this. This is not a discussion about what microservices and distributed applications are. It's more of a discussion about, once we know what they are using them, how do we make them easier? So the drawbacks is that it's complicated. We were before this, in the chat beforehand, we were talking about, they are complicated. If you dig into a microservice structure and you haven't dealt with it before, especially if you're used to dealing with a more monolithic application, it sucks. Like, it seems like it's way more complicated than is needed. You don't really know what's going on behind the scenes. You have to know. It seems like you have to know about every piece of the system to be able to do anything at all to any piece of the system. Things can cost more because you may have all sorts of things that are scaling when they're not supposed to. You have to be aware of what your nodes are doing and make sure you're not blowing out your infrastructure costs. And then trying to monitor all that stuff, going from one app to 10 million apps, that's a big deal. Like, how do you know what's going on in your 50 node distributed application? So that's kind of, some of those things are the things that we're going to try to address here. So my talk's going to be about Tye. This little blurb here, that Tye is a developer tool that makes developing, testing, and deploying microservices and distributed applications easier. That's their blurb for it. It's an open source Microsoft tool. It started off life as an experiment late last year. The ASP.NET Core team had decided that dealing with microservices in .NET kind of sucks, and they wanted to make that easier. So they independently, a couple of their architects went off and did some experiments, and they came back to the table and they hemmed and hawed, and they came up with this thing called Project Tye. There's a whole bunch of history about why it's named Tye, and it doesn't really matter. But ultimately, what it really does for you is it gives you service discovery, what I call easy mode containerization, and I forgot to change these words. I apologize. It gives you an automatic dashboard, and most importantly to me, and to hopefully to people who want to use this, they announced, I think it was last week or the week before, that it will be part of .NET 6. It will be a first-class citizen, not an experiment. Right now, it is an experimental tool, but it will be part of your Visual Studio experience, your VS Code experience, and part of .NET. So that's supposedly coming as part of the .NET 6 next year. So if you do want to use this, you don't have to be too afraid about this going away. It may change, but structurally, they have committed to Tye being an important tool because of what you're about to see. Because what it does is it works on these three pieces. It hides the complexity. It doesn't reduce the complexity, but it pushes that off of your plate. You don't have to worry about all the dependencies. It hides a lot of the complexities about deployment, especially when you move to containerized applications. It makes that a lot easier. And the diagnostics that it provides out of the box, plus some of the add-ins that it has, make it super easy to develop locally with your with microservices and with other pieces like Redis or Search or Zipkin. So I'm going to show a lot of those things. But before I go on, I wanted to again stop for a second. Does anybody have any questions about or comments or arguments about anything anything I've said so far? Going once, going twice.
You're also welcome to just rant about microservices.
Yeah. A lot of people hate microservices, so hopefully you'll come out of this not hating them as much. So I'm gonna flip over real quick to demos now, because that's really what's important here. So we've got 6 of them. I will be posting sorry, let me zoom in a little bit. I will be posting the repositories up to my GitHub. Right now they're private because they were kind of a mess up until today. But if you want to go through these afterwards, I'll pop that out to somewhere and it can get distributed. There's some notes. So this is a .NET 5 and Blazor, so it uses some cutting edge stuff. Doesn't really matter. You can use it with Core. It has to be with Core. It doesn't really work. I mean, you can sort of use it with Framework, but it's not meant to be used with Framework. So if you're in that space, this probably isn't the tool for you. Also, if you're in that space, get out of that space, go to Core, because Framework's going away. But I wanted to kind of take us through a journey of, before we look at Tye, let's look at why we need Tye. So in the beginning, I'll run this app real quick. This is if you create a new Blazor app, new Blazor with a ASP.Core backend. Everyone has seen this app. This is the out of the box. Go get some weather, and here's your weather. This is not. I didn't change anything with that. That's all this is. So this is the place where everyone starts life, and you're like, okay, I've got an application that I need to write, and I'm just going to write it. And it's just going to be, the front end talks to the back end, and the back end talks directly to the database, and there's nothing else going on. Not too exciting, right? But that's how life starts. It's a monolithic app basically, and everything's in one place. There are no external dependencies. Life's happy, right? Okay, so nothing too exciting there. But then we move on to somebody says, hey, you know what? Your weather service, I need to use that somewhere else. So could you pop that out into something that's usable elsewhere? And so because we're smart and we think we know what we're doing, we go ahead and we create a microservice, and we call it weather, and we pull the weather stuff out into just a baby little, it's a tiny little controller that does almost nothing other than gives the data back just like before, right? Nothing too exciting. We have one dependency now. We've got our server is now connected to our weather client. Life's still relatively happy. We do now have to worry about our front end talking to the back end through an API client. So we kind of have to worry about one little port. Normally, I know you wouldn't hard code this, but this being a demo, this is what you get. Again, not too complicated because we've got everything still in one place. This is relatively easy. We have one microservice and one front end app, and that's good to go. So I'm not going to bother running it. It's exactly the same as the previous one, only requests are now made across an HTTP pipeline to get the weather data. So then fast forward a few months and your organization hops into a new mode where they've got customers, and they've also got customers who want to, as demos usually do, they want to do to-dos. So we've got the idea of people and we've got to-dos. Just arbitrarily pulled those out of a hat, but since we've already got our microservice pattern, we went ahead and we created a person and a to-do API. Again, nothing too exciting. We're just using an in-memory database. It's pretty boring. But now we have this problem of, okay, our front end has controllers, and we have to know about 3 different endpoints. Now we have to know about our person endpoint, we have to know about our to-do endpoint, and we have to know about our weather forecast endpoint. Again, you wouldn't normally hard code these. You could pull them out of config, but you'd still have to put them in somewhere, and you'd have to say, okay, I got to maintain these things. Again, not super complicated, but it's beginning to get a little messy. So now we've got our app has changed a little bit. We're using Core now instead of we're using Kestrel instead of IIS Express. But now we've got our weather, but now we have the ability to add a person, and now we have people, and you can add a to-do, which is not too exciting. To-do one, big deal. And these things work, right? I can see my people, I can see my to-dos. Big deal, right? So now comes the day that everyone dreads, and it almost always happens, which is somebody says, you know what? People need to have their to-dos, and to-dos need to depend on weather. We don't know why, but the temperature has something to do with to-dos. So that's what the request has been. So now we're going to intertwine our microservices. You shouldn't, quote unquote, you should not do that. But in reality, that almost always happens. And when that happens, you start to see where madness is going, where you're going to be taken into madness, because now you have your person controller in the API for the person API has to know about where is it? Sorry, down here somewhere. It has to know about the to-do client, and the to-do controller has to know about the weather client, and the front end still needs to know about all of them. And now you've got this sort of dependency chain that's getting a little more complicated. And remember, we only have 3 microservices. If you have an organization that's of any reasonable size, you're going to have a lot more than 3 microservices. So at this point, when we run this thing, we have to worry about 4 different console windows. We have all these things that pop up, and then we have our front end. And it's like, if something blows up, how do I know what's going on? Like, where do I go to find that? So if I go to weather and I do a request here, I have to find the weather window, wherever that is. I'm not even sure, blah, blah, blah. I don't know. It's one of these guys. So I have to find it and have to find the logs. If something blows up, I need to know about it. I need to know how to run all those things. I need to make sure that there aren't port clashes between all those projects. And if someone else wants to use my weather service as a piece of code and not just an API, they also need to make sure they're not running on port 5003 or whatever it is and all that kind of good stuff. So it quickly becomes a problem. So if you've worked in microservice space, I'm fairly certain you've seen this. I mean, that's a pretty common scenario where you've got a set of services that are talking to each other and a set of clients that are talking to the services. And it becomes one of these things where unless you were there at the beginning, there's no way you can know about how all that stuff works together. Why as the person API developer should I have to know about how any of the rest of this stuff works? But you do, because we've made the decision in the organization to tie person to do. That might not be the best choice from an anti-pattern perspective, but that's what we needed to do because time crunch, whatever. So that's a problem, right? That is a micro version of what becomes a massive problem. If you had 50 of these services, that's a problem. Do you really want to have to maintain 50 connection strings and all that other stuff? Do you want to have a solution that has all that stuff in it? Do you need all that stuff? Well, formerly you kind of did. That's just the way it was. But now we're finally going to get to Tye. So I apologize it took this long. But now we can actually get to Tye. And what we can see is I did a diff between the 4 and the 5, so the previous repository and this repository. And the only things that have really changed is that we've added this NuGet package. Sorry, I can't zoom this in for some reason, but there's a NuGet package for Tye. And in our startups, we've used the Tye method of get service URI. And all we do is we pass in the name of the project that holds that information. So I'm going to show you how this works in a second, but let me just, I'm going to come to my command prompt here, and I'm going to go to number 5. And all you do in this world is you do Tye run. So Tye run is, it takes all of your dependencies, it finds them. So you can see it found the front end for the server and the client, the person API, the to-do API, and the weather API. It gave them fresh ports, fresh random ports. And now they're all going to be connected together. And on top of that, out of the box for free, it gives you a dashboard. So everything that's part of what it discovered is here. So you can see, these are the URLs it gave for the projects. These are the URL. This is the URL for the front end. You can see the logs for everything here. You can hop to here, certificate warning. And you can see that this is now running on this port. I don't have to know anything about any of the other services. This front end can run. It doesn't care. I didn't have to type any of these ports in anywhere. It just magically worked. And really the way that it does that is through this guy, through a Tye YAML file. So just to show you that guy, it's very basic. It just goes and discovers everything that you have. And it gives it a name based on the folder and the project name. So the name is essentially just the project name minus csproj. And you can refer anywhere in a .NET Core app where you have the Tye extensions, you can refer to this and you'll get the proper connection strings for that API, or you'll get the proper URL for the front end. So, I mean, that's kind of cool, right? I mean, it gives you a central view into what's going on. Like I said, you can see all your logs. You can see, you can add, if you need to do load balancing locally, you can add replicas easily, which I didn't do in a demo, but you could have 3 of these if you wanted to, and it'll magically do that load balancing for you. So that's the baby version of Tye. That's the simplest thing you can do with Tye. That in and of itself is useful because it gives you it glues everything together without you having to manage, 50 different microservices and connecting to each other and yada, yada. You don't have to worry about that. So before I go on to the magic version of Tye, are there any questions on this? And I don't know, Drawbacks, is there anything in chat either?
Not yet, no.
All right.
I've been watching it.
So this is kind of magical. It's a little underwhelming, but it's because you can do all this. But if you were to imagine you had 20 more APIs, this becomes more useful just by itself. But where it gets really interesting is when you get to some of the containerization stuff that Tye can do. So the last demo I'm going to do, and this is my favorite part because it's the most interesting one, is in this one, we're going to add in the ability to see dependencies between the services, and we're going to add in the ability to add the elastic search stack to this application with essentially 2 lines in the YAML file. So this solution here is identical, exactly identical. This is the same as TyTalk 2020-05. It's the same exact thing. The only difference is this. That is the only difference. I've added 2 extensions, a Zipkin and Elastic, to my Tye YAML file. So I'm going to run this now, and in order to do this, you do have to have Docker installed. So I'll put that in the instructions in the core. But you can see up here, you can see that it's automatically downloading Docker. If I didn't have these, it would have already downloaded them. It's getting Elastic, and it's getting Zipkin ready to go. It's giving them ports. It's giving them all sorts of neat stuff. And again, because it's magic, it actually adds those. If I can refresh this, it actually adds those to the dashboard. So not only do we have Zipkin and Elastic, but we actually have them on our dashboard. They're hosted wherever they need to be hosted. If I have 2 sets of microservices running, the second Zipkin will get a different port, all that kind of good stuff. So what is Zipkin? If you haven't seen Zipkin, this is Zipkin. So Zipkin is essentially the ability to see what's going on in your application. So I haven't done anything yet, but if I go over to my application now, and I actually do some stuff, yeah. Accept the risk. If I actually do things, so I look at my weather, I add a person, and I add a to-do. So I do everything that this app can do. So I've done pretty much everything. If I go over to my Zipkin, and hopefully it'll give me some stuff. I need to be later in time. Sorry. So it automatically created a dependency graph for me out of nothing. It discovered that my front end talks to the person API, and it talks to the weather API, and it talks to the to-do API. The front end also, the person API also talks to the to-do API, and the to-do API talks to weather. So you can already see that we're dangerously approaching a cycle here, a cyclical dependency between our microservices. So Zipkin can tell you, hey, you've got this stuff going on, and it'll show you each of these little spheres going along the lines. Those are the calls that I made. You can also look at what's going on. So you can say, okay, what happened with when I went to get a person? You can see that the front end server went to itself, and then it went to the person API, which then went out to the to-do item API, which then got the to-do items back. And it tells you how long each thing took. So you can see if you have performance bottlenecks. And again, all I did was I added one single line to my YAML file, and now this is here for me. And that's important to call out, is this is here for me. This is not being infected by other developers' activity. It's not showing anybody but my own activity, so I have a clean, fresh environment every time I run my local microservices, so I don't have to parse through millions of other people's activities or other database stuff or any of that kind of stuff. The other thing that I just also did was I gave myself Elastic, which is this guy. And so again, this is I'm running on my local host, running in a Docker image. And it essentially, it allows you to see all of your logs from all your applications in one spot. So if you've ever used Splunk or if you've ever used Elastic, this is it. You can do regular expression searches. You can say, okay, I'd like to only see, weather API calls. So you limit to that. You can see how many calls are being made in any individual moment. So this is, again, if you were to configure this yourself, if you were to go out and say, okay, I would like my little app with my 3 microservices to have Zipkin and Elasticsearch, it would not take you the 10 seconds it took to do it with Tye. It would take you a long time to set that up, a long time to figure out how to configure the Docker images. You'd have to understand Docker. You'd potentially have to understand Kubernetes if you were trying to deploy this thing out. So this alone, these features that we've just looked at, just giving us the service discovery and the ability to have observable extensions added to your local environment so that you can actually see what's going on is a complete mind blower for anybody who hasn't had that stuff. Because if you don't have this, you have to know which of these things are connected. You have to make sure your local app settings are set right to point to the right things. You have to make sure everything's running. You have to make sure all that stuff's working. With this, you don't have to do any of it. It's just all transparent to you. So if we go back to here real quick, the complexity is still there, but we don't care about it anymore. We don't even care about the dashboards, or the dashboard shows all of our URLs. We don't care about if we wanted to add Redis or any other Docker image, we could add it just through one line in the Tye YAML file. As far as deployment is concerned, I don't have a demo for this, but it's going to be in a future talk. You can take what we just did and actually turn each of those things into containers and drop them out to a container store. And then obviously with diagnostics, this is a huge one. I mean, you can see it immediately how easy it is now to see what's going on out in my application. So again, you've got fully enterprise level search running locally, and you've got Zipkin, which tells you all of your server dependencies and what's, all the call chains and the diagnostics in terms of timing, all with almost no effort. Really and truly, I know that this might really feel like magic, but in order to make this work, like I said, all you need to do, if you have a solution that doesn't have this, you go to your solutions directory, you install Tye first, you go to the solution directory, you type Tye in it, it finds all your stuff, and then the only other thing you have to do is you have to go out and you have to, wherever you're hitting services, you need to pull the configuration out this way rather than whatever way you're doing it now, and then you're done. You're good for, that's all you have to do. You go Tye run and you've got this. If you want to add in the Zipkin and the Elasticsearch, you have to install Docker, which you do have to do that. You have to do that one time, and then forever after that, every Docker image you want just automatically gets pulled and installed by Tye. So it really is, if you've been in the microservice space or just in distributed application space in general, it really is magic. Like the first time I saw it running, I was like, okay, that's kind of lame. But then when you see what you can actually do in the diagnostics you get, it changes. Like when you have to diagnose a production error, you can get the latest code, run everything locally, and you can debug your entire space of microservices and everything else connected to them without having to worry about anything that's been changed since the last time you pulled it, any configuration changes, all that stuff's handled for you. So it is a game changer when it comes to local application development. And again, it does have it. I don't want to do it disservice. It does have the ability to take this and take it to the next level and get it to production, but that was kind of too much to put into one talk with Dapr. So I think I'm gonna leave it here for now. That's the fire hose version of what Tye can do for you. If you take nothing else away from it, if you're doing microservices, just try it. Get Tye, get Docker, use Zipkin and Elasticsearch, and you'll see in 1 hour how it changes your life when it comes to microservice development. Truly, it really is. It's one of the few sort of game-changing technologies I've seen that is sort of independent of whatever platform you're running on. If it's Blazor, if it's MVC, whatever it is truly powerful for, as the talk is, untangling your distributed applications. So with that, if there are any questions, I can take them now. If not,
yeah, there was a quick question by Joachim Landis. Have either of you seen this used in a prod or pre-prod environment? I
have, because I'm working with a client that gets to be the guinea pig for this. So yes, not production, in local dev. So the Tye developers themselves, it's interesting. They have said, if you attend the .NET stand-ups, they pop on every once in a while and they talk about Tye. They had envisioned most people using it for containerization and to get it to deployment. And it actually turns out that about 80% of the people that use Tye only use it for what we just saw here, because it's so powerful to go from this crazy hodgepodge of all these different projects you have to know about to this. So I would say my prediction would be that Tye will become 2 different products in the future when it actually gets put into the .NET 6 world. And one will be for the containerization support, and one will be for the inner loop local dev. Anything else for now? If you think of anything, I know that was a lot of information. I know I was talking fast. I wanted to leave time for Abdulrahman's talk, so I know I was kind of blasting through that stuff. But again, I wanted to show you that journey we took to go from a monolith to a distributed app without having to worry about all of the garbage that goes along with the distributed app. That's a journey that most people should want to take, because a lot of people get stuck in the previous step where you have 30 microservices and you've got 50 different apps using them, and you don't know how they all work together, and you don't want to know how they work together, and you get a ticket from your support system that says go fix this thing in the middle, and you just want to quit because it's like I don't even know how to get those things set up anymore because I haven't touched them in a long time. This fixes all of that, and you do not have to choose between Tye and not Tye. You can run them both. You can run this without. You can just put this. You can put that in your app settings if you want to. Real quick, I'll just show that. If you want to use those without Tye, you can just uncomment this stuff and you can get those same exact settings. So the last thing I'll say, and this is not going to be part of our demo today, but Dapr and Tye have a lot of people who are working on those two projects together, and those tools are now kind of designed to work hand in hand. So there's going to be some overlap with what Abdulrahman is going to show you. And there's also going to be, there's a whole nother set of Tye tooling around Dapr that we just aren't going to have time to get into. But hopefully in a future talk, we can show them actually working in tandem. And you get the best of both worlds. You get the Tye magic and you get the Dapr magic. So just wanted to throw that out there. So with that, I'm going to turn it over to you, Abdulrahman, and we'll see what we get.
All right, that was very exciting. Thank you so much, Jess. And I'll continue to hopefully keep the energy up for this one. Let me go ahead and share my screen. Can you guys see my presentation right now? All right.
Yep.
Sounds good. All right. So my name is Abdulrahman. I'm also an engineer at Polaris Solutions, as I mentioned. And we're going to continue speaking about microservices and all the different challenges. Jess had mentioned about the complexity, deployment, and diagnostics that we kind of were able to tackle utilizing Tye, the different issues that we ran into. And what I'll want to do is kind of go over those again very quickly, then talk about the different issues we face, and then introduce Dapr and how it goes about solving some of those issues. I'll then end it with a very quick demo and how it works. And as Jess mentioned, this is a very open, so feel free to ask questions whenever. If I have the answer, I'd be more than happy to answer it for you. So the issue that we were having was the complexity can grow out of hand very quickly. Same with the deployment, and really hard to just diagnose your issues and debug through the problems. I won't spend too much time digging too far into it because it just did a fantastic job of explaining what kind of the issue is with the demo that he presented. And so Dapr helps target to alleviate the issues that tend to come up in our way. It specifically tries to minimize the complexity and assist with the deployment phase. So very quickly, let's step up. What is Dapr? Dapr stands for Distributed Application Runtime. And as we've seen, not all frameworks are created equally, nor with the same standards or compatibility in mind. Some of those come into mind, like OpenTelemetry and other standard practices. Not all of them utilize the same languages. Not all of them target the same operating systems, and the support varies per framework, it also depends if you're deploying it through a virtual machine or Kubernetes. All these make up the kind of a very complex solution that Dapr does a fantastic job of tackling. What it does, Dapr abstracts out a lot of these issues and allows you to connect them together by just exposing the APIs through an HTTP or a gRPC call. And I'll get into a little bit more detail about that in just a little bit. So this is kind of a quick a picture of what Dapr components look like and how it kind of communicates. Dapr codifies the best practices for building microservice applications into open, independent building blocks that enable you to build portable applications with a language and framework of your choice. So what does that mean? You're no longer limited by just one language, and you're no longer limited by a legacy microservice that was done in a previous language that now you want to upgrade to a different one. it allows you to interchangeably utilize them as you will and as you want. Each building block is completely independent, and you can use one, some, or all of them in your application. It's kind of an a la carte mode. You kind of pick and choose. It's very easily extensible. Dapr is also platform agnostic, meaning you can run your applications locally or on any Kubernetes cluster and any other hosting environment that Dapr integrates with. And Dapr does a fantastic job of integrating with a lot of different, very standardized frameworks and platforms out there. This enables you to build microservice applications that you can run on the cloud, edge, or any other platform. There's a lot of built-in support for AWS, as you've seen at Microsoft Azure, and Kubernetes. Let's move on to the building blocks. So these are the different building blocks that make up what Dapr is. There are many considerations when architecting microservice applications. Dapr provides best practices for common capabilities when building these applications that developers can use in a standard way and to deploy to any environment. So it combines all the different practices that people have culminated over these years and all the different things that have worked, and makes it a very standardized, simple process. It does this by providing distributed system building blocks. This is very important. Each of these are very unique, as so service-to-service invocation, state managers, all these are different building blocks that make up Dapr as a whole. In the initial release of Dapr, you'll have access to all the building blocks that are on the screen over here. And there are current work in progress since Dapr is a newer application that are continuing to expand on this. To speak a little bit more to the different blocks, you have resilient service-to-service invocation that enables method calls, including retries on remote services wherever they are located in the supported hosting environment. It'll do all that for you. You don't have to continuously keep making sure to keep up with your service or listening to it. You can set it up that it will have an automatic state management system for storing key value pairs for long-running, highly available stateful services that can now be easily written alongside stateless services in your application. So you're no longer limited to one or the other. The state store is pluggable and can include Azure, Cosmos DB, SQL Server, PostgreSQL, and Redis, among many, many others. This also gives you the ability to publish and subscribe to different topics, events, or services, so you can have resource bindings and triggers. This will allow you to, for your logic, to react to external plugins without having any actual Dapr code live on that external plugin or application. Dapr is smart enough to be able to pick up on that and know how to read off of it. That's all very amazing, but how does it do that?
Hey,
yeah.
Can you go back to the previous slide real quick? So just to recap, does everyone? I just want to make sure everyone understands that these slices here are all important pieces of developing a distributed application. They're not unique to Dapr. They're just Dapr accommodates them. So just to make sure that's essentially what this picture represents, is that if you're doing an enterprise distributed app, you're probably going to need to deal with most, if not all of these. So Dapr provides a nice abstracted way to do each one of these things. That's the important takeaway here, is you don't need to know what all these are, but these things are all super powerful tools that make distributed apps possible, and Dapr really kind of magics them up behind some stuff that Abdulrahman is going to talk about next.
Oh, absolutely. And another very important thing is that all of these are very important, but you can also pick and choose as needed with Dapr. You don't have to go ahead and buy everything under the sun. You can just pick and choose the pieces that you need. So getting into how it does this is it does this through the Sidecar architecture. What this means is that you'll have your application code running, and based on the image here, you can kind of visualize it through the gray box on the left. And it exposes as if you're talking to any REST API, exposes through HTTP or even a gRPC endpoint, and Dapr is able to pick up on that. And through the Dapr API, it will then automatically take you to all the other services and that it's able to connect up with. And this is regardless of whether you're running this locally, so it will go ahead and run on localhost for you, or if you're running this spun up on a virtual machine or Kubernetes cluster. So Dapr will essentially spin up a instance for you and connect to your microservice, no matter how many instances of microservices you have. And it's smart enough to be able to pick up as well on ones that if you like, kind of how just mentioned, if you have multiple instances running up, it'll automatically kick up and boot up for each one of those and kill itself when those go down. So the next slide kind of shows the same thing, but with it explains how it runs in parallel to your application, but with a little bit more details. So back to go ahead and give the example on you have your gray boxes where that's your where your service currently lives, and that's where your code. It doesn't know anything about service B, and service A doesn't know about service B, and service B doesn't know about service A. They're very independent. They live on their own. All they have are just HTTP endpoints that it exposes, or gRPC for that matter. And then you just wire up a Dapr sidecar that will go ahead and run in parallel to this. And as long as that communication between the Dapr sidecar and your microservice exists, Dapr can connect your microservice and go ahead and set up bindings to Twilio, Kafka. It can set up observability. It's kind of how Jess mentioned with Zipkin. All this comes automatically for you with Dapr. You can set up Jaeger for UI insights. Very similar as well. Very powerful tools. You can set up store management with Redis. Same thing with publish and subscribe. This is very, very powerful, and it simplifies it again by just the URL for the microservice that you're targeting, and it exposes it as an API. And it does the same thing as if you're running on a Kubernetes cluster. Here's a visualization of how that would look like. We'll just spin up different instances for your application, and it will automatically boot them up for you, and it knows which ones to connect to. And as I had mentioned, again, this can automatically read off different it'll be reactionary to different event triggers if need be. Any questions so far? I know I've kind of been throwing out a lot out there. If nothing, then I'll just continue on. There's also additional SDK support for this. To make using Dapr more natural for different languages, it also includes language-specific SDKs specifically for Go, Java, JavaScript, .NET, and Python. These SDKs expose the functionality in the Dapr building blocks, such as saving state, publishing an event, or creating an actor through a typed language API rather than calling the HTTP gRPC API that I was mentioning. So it also offers that. This is only offered for very specific languages so far. It's currently under development to improve and expand. So any feedback on this as well I'm sure will help the team grow. So this enables you to write a combination of stateless and stateful functions and actors all in the language of your choice. And because these SDKs share the Dapr runtime, you get cross-language actor and function support across multiple languages. So I'll go ahead. I prepared a quick little demo to kind of go over this. I've borrowed the demo from Cecile Phillip. He gave a webinar earlier on Dapr as well. I would recommend, if you want to go ahead and get a deeper dive specifically on Dapr, to view his webinar, or they have a deeper dive on through Dapr docs on their webpage as well.
Hey, wait, before you hit the demo, we do have a question. It's actually the question is, how does Dapr differ from an application gateway? So let's make sure we're all talking about the same thing. So when I will butcher this name, Jay Krishnan, is that even close? When you say an app gateway, do you mean essentially like the front end for client apps to talk to back apps, so it gets routed to the right place? Is that what you mean by an app gateway?
I'm talking about more like API gateway, to be exact, which has the sidecar and it has the functionality what you are describing?
Yeah, there are pieces of Dapr that are like that,
Right.
but API Gateway doesn't have anything about observability. It has a little bit. State store, PubSub, all those kinds of things. Those are kind of behind the scenes magic that occur on the other side of the API Gateway. So it's a good question. It does overlap. Some pieces of it do, but there's a whole lot more to it.
Right. Yeah, and just to piggyback off of it, Dapr is a pick and choose of all the list of all these different components that I had mentioned over here. So lots of these are not just API gateways. They expand a lot more outside of that as well. And as Jess mentioned, it does a lot of the management and communication between these APIs for you, rather than just exposing the API calls.
And you can, if you would like to, especially if you're talking about like Azure API management, for example, you could use Dapr in conjunction with that as well. It's not an either or situation. So It is definitely a very pluggable product or framework, I should say.
Okay, thank you.
Thanks for the question.
Yeah.
Where are the rest of the questions? Is this really that boring, guys? Come on. We're pulling rabbits out of our head. No, it's kind of boring, I know, but it's kind of cool, right?
Yeah.
All right, go for it. Go for your demo.
All right. So here's the quick demo. As I mentioned, I borrowed this from Cecile Philippi. They had a great app, Contos Crafts. It's set up not in a way that you would normally set up your applications, but if you can see my Visual Studio code page over here, you can see that you have the checkout processor, which is just a very simple Dapr controller. Nothing all that special. Exposes the checkout. And then you've also got your products API that is broken down into, and then also the front end website. This is an app that's essentially running on a UI on a server-side Blazor. The products API is running its own service on a MongoDB, and the checkout service acts as a messaging queue triggered by checking out. An example, just to run this app real quick, let me pull it up. So here's an example of this app. It's currently running on my local host. It's nothing all that complex about it, just a very basic shopping one-page application. You can click to see more details about the page. You can click add to cart, it updates it real time. Add a couple of these, click to view the cart. You see the different quantities that were added, and then you can do submit. It will go ahead and send that message across through the different services. So with this setup in mind, Dapr has a lot of power that I won't go into, but it can mimic a lot of what you've seen that Jess went over when it comes to the different diagnostics and different tools that you can see. What I will do though is that I'll show all you need to do to add Dapr to your application is to have this Docker compose over here. And it's essential, if you're familiar with this file, you're defining services. This is fairly standard stuff, nothing all that special. And you're defining the port that it's going to run on. The only additional Dapr part is that you're also adding the Dapr a sidecar command for it. And this is just what the command ends up being. That's all it does. And then once it does that, the application is smart enough to scrape through the components file, and it will look through the different YML files for the different PubSub, different state managements. You can set up secrets, you can set up tracking, you can see you can set it up through Zipkin over here. This is how it would be set up, and it will automatically take care of that. Let's say I wanted to, one of the coolest things that I found about Dapr, which you can also do with Tye, but I wanted to go ahead and put this into the demo, is that let's say I wanted to go ahead and debug through all of this, kind of how Jess was saying, I have many different microservices. I don't know which ones was kind of, causing the issue. All you can do with this one is that you can just click on submit the breakpoint over here. And then I will go into Visual Studio Code, go over here, and then just tie my my checkout processor to it, and then tie it to this one. And then I'll just pick these are the different services that are running on this current solution. So I'll just go ahead and check out click the checkout processor. It went ahead and added it, and now as you can see, it's doing some things out in the debug console. It's starting up. So let's go ahead and give this a shot, shall we? So I'm over here shopping through my things, clicking through a couple of them. That sounds good. Let's go ahead and hit submit then and see what happens. And if on my screen, you can see the flashing yellow, the orange symbol telling you that it hit the debugger. And as you can see here, we've hit this. I can click through and see the different values that exist through this. I can do anything debugging that I would normally do through a debugger. I just step through this clicking F10. And then you can see that this is where the event was hit. Can do F10 again. The order was received and it went through without a problem. And again, to tie this back into how the Sidecar works, all it does is that it exposes this /checkout API, and Dapr knows that, okay, this is where this is connected to. This clearly will go ahead and run this microservice. This is how I can connect this. And it knows how to connect it through, if I was running through RabbitMQ, I can go ahead and check it out through this. And the difference between setting up your different environments and the different pub sub is just as simple as setting up a different YML statement. So if I was running this and checking through RabbitMQ and checking through my statistics, I can go ahead and just delete this. And then all I would do to rerun this is I would just run docker compose up. And this will go ahead and reread through this. If RabbitMQ is deleted, it'll now set up Redis as the default state management service for me, just automatically. I didn't have to do anything else. Just by simply deleting this and recompiling it, it knew what to do and how to set it up. That's kind of what I had for the demo. Any questions on that so far?
There's nothing in the chat.
Awesome. I'll take that as good news, and then people are very entertained. So
yeah, and I think one thing worth pointing out is, as you said, I forgot to do it again, but yeah, you can, just like you can debug into those into apps with the Dapr model, you can also do it with Tye. So running Tye run doesn't mean you're just running it. You can also debug those things too, so you can actually step through code and see things. I forgot to show that, so
yeah,
call out.
Both tools have both capabilities that we're demoing right now. Just for the sake of time, obviously we're not capable of demoing all of it right under the sun. So as we've seen, Dapr and Tye are very powerful tools and very configurable. They can be easily utilized as a full solution or as an a la carte for your needs. On that note, we at Polaris have experience working with many different types of software architecture and frameworks. This may or may not be the perfect solution for your application. Whether it is or not, we have experts such as Jess over here and many others on the leadership team that can help take a look at your current environment and look at the different solutions to find the needs to implement the best solution that is directly tailored and customized to your needs. That's all I've got. I'll hand this back over to Jess.
Yeah, so that was a lot. I know that, as Abdurrahman just said, there's a ton more to show. It would be impossible to show it in one demo that wouldn't take till the end of time. But the important pieces to take away from this, I think, depending on where you are in your distributed application journey, if you're at the beginning or you're in the middle or you're really mature, each of these products can play a role. I would say if you need sort of the elevator pitch statement or the one sentence pitch for what these things do, so Dapr is more of a framework, and it requires you to know. You do need to know like about Docker a little bit. You need to know about Helm a little bit if you want to do some of the fancier stuff. Whereas Tye is more of a runtime, and Tye is almost like Docker Lite. It's almost like or maybe like Kubernetes Lite. You can do containerization like stuff without understanding what a Helm file is or what Docker Compose is or even what Docker is. You just need to know you have to install it. They go hand in hand. Tye can take away some of the stuff that Abdurrahman was showing in terms of those YAML files. It can actually handle those for you, so you don't have to even worry about the Docker Compose. But it's just, the takeaway here would be distributed application development is inherently more complicated than monolithic development when it comes to organization and maintenance. These two tools, either alone or together, are designed specifically, really and truly, they're specifically designed mostly to make our lives easier. They're written by developers, for developers. They're meant to take away the pain of that inner loop where you're local and you need to run a bunch of other stuff and you just need to get your job done and you don't want to dick around with all sorts of other stuff. That's what it's for. So I think if you take away nothing else, probably your easiest jump would be to start with Tye. Dapr is a much bigger lift, but it's also a much bigger product too. It can do a lot more. And if you're not on this journey, don't dive into this unless you need to, because it's not going to make your life any simpler if you're in a monolithic space, or if you're like Tye doesn't work very well, for example, with containerization of older stuff like framework and things like that. So there are use cases where it doesn't make sense. So take it with a grain of salt. But these tools, if you're in this space, definitely take a look at it for sure. It can change your life, and if you need to sell it to your management, the answer is, in terms of time to responsiveness on both getting new work out and fixing production issues, is reduced by orders of magnitude when you have tools like this.
Exponentially, yeah.
Yep. So that's about it. I don't see any more questions, but we're available via email if you have any questions about how this stuff works. Like I said, I'll be posting these demos up to my GitHub repository or my GitHub space, so you can see that stuff if you care. I'll probably be expanding on it to show the Dapr connections later, and we may put together a talk later for sort of the more advanced version of this. But we kind of wanted to judge sentiment and see if there was any excitement in the community about this kind of stuff, because it's stuff. I mean, a lot of us deal with this on a day-to-day basis, and it can actually be disheartening to go into work and be like, oh my God, I have this huge system that I have to work with, and I don't even know how to get to these things. So, we'd be interested to hear either now or later any comments on, does this even seem like it would solve? Is this a problem? Is this a solution looking for a problem, or are these problems you guys are actually having? And if not, well, we could just leave it at that. I see Joachim's typing something. Oh, someone's saying something too.
Will I be able to find your GitHub space just by searching for Jess Likens?
You should be able to.
Okay. I'll try it out. Okay.
If not, it's J Likens. That's my repositories, or my space is J Likens. These things will be public probably tomorrow morning or tonight. Joachim had said, I can see Tye help very easily for local development, for new development. Absolutely, that's a great call out. If you're a new developer on a giant distributed application, you're looking at 6 months before you even understand how anything works. With this, you may still need your 6 months to understand the full system, but if someone gives you a ticket and shows you how to use Tye or Dapr or both and says, you need to go fix the person API, well, you have the ability to actually run it and get there in a way that you don't have to know about the 10,000 other microservices. You can actually get to that point and be productive quickly. So yeah, that's a great call out, Joachim. Anything else?
As I say, I think a lot of us are just, absorbing everything that you shared today. And for those of us that haven't had to really set up a lot of microservices and all, what I kind of see what you've shared is that I mentioned the macro management of microservices, and this is kind of feels like, the glue of a lot of that, a standardization around a lot of that yes. Really wasn't really there, I guess you'd say, even a few years ago.
Yeah. Right.
So I like that you said at the beginning that, it's a project now, but it looks like it's, something's gonna be baked in 6.0, which is great. So there's a standard that you can kind of base your architecture around and how you debug locally, and then how you just kind of, have something to have a basis on as you break things up within the architecture.
You're exactly right. That's a very good characterization of it. It's very much about, and one thing that I didn't have time to demo, just to piggyback onto that, is most times you aren't going to have your person microservice and your to-do microservice are not going to be in the same solution. You shouldn't have that. But with Tye, you can pop down to your root directory where all your repos live, and you can tie together other Tye YAMLs. So like, let's say the person YAML and the to-do YAML are both there for Tye. You can do a Tye run up one level and actually tie those together with their own Tye YAML. So you can actually go across your repositories and not have to have a lot of folks wind up having one giant solution with everything in it just to make sure you didn't break anything. With Tye, you don't have to do it that way. So yeah, there's a lot of cool stuff coming, and the developers of it seem pretty excited about it, and they seem like they're having like internal battles about who can make it better faster. So like they're about to drop a VS Code add-in, just like the one that Abdulrahman was showing with the Dapr. There's going to be one for Tye. So yeah, there's a lot of movement in this space because they recognize that this is where the industry's going or has already gone. And .NET, to your point, John, it's been kind of crappy in that space. Like managing this stuff, there hasn't been anything out of the box for it, and there should be. So we're headed there. We're headed there.
Well, I have to admit, a lot of times .NET developers kind of really like that guidance, before we kind of break apart our monolith application into 20, 30 other apps. Having something that really kind of makes that manageable and to where you're not going down the wrong path. I've seen and been a part of, applications that the types of services that they were getting broken out and weren't really microservices. They were just multiple web services. Mm-hmm. So having something like this kind of be in the space and was something you can kind of even see how people are applying it in different examples it's really good to see.
Yeah, it bridges some gaps for sure. And if people are interested in it, I do highly recommend, if you have time to give up your lunch, it happens in Central Time's lunch time usually. The .NET Community Stand-Up is a great place to go to see what these guys are doing, because they talk about this every few weeks, and they drop a new release for for Tye every 4 weeks. So this is a moving target for sure.
Wow.
We do have a question that came in from Jamie Bowman. What about I believe that's service meshes? How does Dapr compare? Can they work together well? So by service message, you mean more about network concerns. Is that it? You want to take them?
That's what I would guess. I mean,
yeah.
Because like for example, Service Fabric in Azure, where you can dump a bunch of microservices into the same shared memory space. If that's what we're talking about, I don't know. I'm not sure that I have an answer for that, to be honest. I don't know if you do.
Not a super in-depth one, since I don't know a whole lot about service meshes. But my understanding is that Dapr is just a little bit more abstract than that, and it allows you to do more than just monitor things across the network or configure it across that way. It actually, you can inject code, or you can set up code and logic utilizing Dapr as a development platform. It kind of goes back to the different pieces of Dapr that I showed in the slide, and the different components. I would say it probably does perform a similar service, but it can expand more on that if you wanted to. That is my educated guess.
Yeah, I would assume, to piggyback on that, because Dapr is a Microsoft written framework, and because it can utilize gRPC, my guess would be it is a relatively painless drop-in to at least into Service Fabric. I'm not sure about, for example, AWS or Google Cloud, what that would look like in those spaces, because I'm not exactly sure how they containerize within the service mesh. But I would bet, if you're talking Azure, I would bet it is almost seamless, based on what you showed here, Abdulrahman, and what I know about Service Fabric. Again, those are educated guesses, though, so don't take that to the bank.
Right. Great question, though. Thank you.
William, you're at that F5 ability of other boatload of manual config file changes. Exactly. At the last place I worked, we did it was a bunch of people's first microservice implementation, and we had a lot of that stuff where it's like, okay, nobody wants to add a new microservice because of the pain involved in connecting it to other microservices, making a build for it, containerizing all that stuff. So yeah, this if you've been here, I hope that you recognize the pain that this will solve for you, because it really, for me, it's like, okay, this is a Band-Aid or a bandage that I've needed for a long time for my soul when it comes to microservices. Oh, Monica's leaving. See you, Monica.
It's great.
Anything else that we can make fun of or dance for you or anything? Anything you?
We can try to do the presentation and interpreted dance. I don't
If
know
you- If anybody wants to learn Rocket League moves, Abdul Rahman's your guy. He's a Rocket League pro. If anybody needs,
I don't know about a pro.
anybody needs Rocket
I
League
struggle.
tips.
I don't know. My 10-year-old's pretty good. So
Yeah, he's probably better than me. Not gonna lie.
yeah, he's definitely better than me. So yes.
Hey, my little brother is amazing at it. So yeah.
Mm.
Yeah.
Well, I appreciate it, guys. Yeah, if we have no other questions, really appreciate this, and I'll put this out on YouTube, a little later on tonight.
And is there a general way, if anybody wants to talk to us, is there like any place where we can dump our emails? Just throw it in chat, or is
I would
that
say
on
throw
the
it in.
Meetup?
Yeah, I would say throw your emails in chat or how you want to be connected with, and yeah, appreciate your time, guys. This is really good.
Thanks for having us.
You guys can put your links to your slides and your emails in the Meetup discussion. That would be good.
Sure.
Yep, can do. We'll do that after this. Well, thanks, guys. You've been a great audience. Hopefully nobody fell asleep. Tried to keep it quick. Tried to spray you with the fire hose of information to keep you on your toes.
Well, I'll be honest with you. This is where this talk really helped me pull together where thinking about microservices, just take it a lot more serious, because that standardization really feels like it's coming together in the .NET space. So yeah, I was more so just thinking about how it'd be more and more applied to what I'm doing. So got a lot out of it. It's very good.
Great. All right. Now what?
That's it, guys. I'm hanging up.
All right.
You guys have a great night.
Bye, everybody.
Bye.
Take care. Bye.
Bye, guys. Great job.